Okay, compound angles. So we're going to start here by looking at the use of the double angle identities. Okay, so in question 1 here, we've got to find all the results of theta between 0 and 360 satisfying this equation. Now with sine 2 theta, we've got the result of that being the same as 2 sine theta cos theta. So we can replace sine 2 theta with this, and of course that equal then to cos theta. So my equation from here becomes this. Now in the next step, you have to be really careful here, okay? You might be tempted to divide through by cos, so the causes will cancel, but please don't do that, okay? We're not allowed to do that because cos could actually equal 0, couldn't it? Okay? Cos is allowed to be 0, we get results for it, and that means then if you divide by cos, you could be dividing by 0. We're not allowed to do that. So what you should do instead is take the cos theta over to the other side, so it becomes minus cos theta. Okay, and put that then equal to 0. Okay, you then have two terms, and we can see that cos is a common factor, so we can factorize it. So cos theta bracket, while to get 2 sine theta cos theta, I've got to times cos theta by 2 sine theta, and to get minus cos theta, I've got to times this by minus 1 equals 0. And we've got a situation then where we've got two things times together equals to 0. Okay, got the cos theta times this bracket equals 0, which means one of them must be 0. So either cos theta equals 0 or 2 sine theta minus 1 equals 0. Okay, one or the other. So if cos theta equals 0, those results can come quite quickly. Okay, if cos is equal to 0, or if it is equal to 1 or minus 1, what I would do is just do a quick sketch of the cos graph. Okay, it doesn't have to be like spot on, okay, because we're not necessarily thinking about symmetry like we are going to be with the result for this. We just need to remember the shape of the cos graph. Okay, so it goes something like that, isn't it, roughly? Okay, and in the case there where it's equal to 0, you can spot straight away is here and here. Of course, if that's 0 degrees here, that's going to be 90, that's going to be 180, so that means that's going to be 270. So the two answers we want are 90 and 270. Okay, so we've got two answers for there. For this one, well, we're going to solve this, so take that over, so you get 2 sine theta equals positive 1, so then sine theta equals to 1/2. Okay, so then we'll use our calculator to get a result here for theta. Okay, and if you do that, you get 30 degrees out. Okay, and remember, that's just one possible solution, but we've got to look at the solutions from 0 to 360. So in that case then, we need to draw the sine graph. Okay, now in this case now, I will sort of put a bit more detail in with the sine graph here. Okay, in terms of the scale, because we want to see the symmetry, yeah? So with the sine graph here, you could, for instance, go every 3 centimeters to represent 90 degrees. And this is a nice simple one, and simple solution is going to come out now. So we've got 0, 90, 180, 270, 360, okay, and that's what we need the angles for. And we know that it's got a maximum of 1 and a minimum of -1. So again, we remember from before, from last year, if you can't remember what it looks like, the sine graph, just put sine 0 in your calculator, and sine 0 is 0. Put sine 90 in, type sine 90, and sine 90 comes out to be 1. Same with 180 is 0, 270 is -1, and 360 is 0. So you get this sort of like zigzag here, but of course we need to have a wave, okay? So then we have the sine wave. So turn it around to help you to draw it. Okay, and it does kind of look a bit like an S, doesn't it then? Okay, just like this looks like a C there. If you turn it on its side for the cos. Okay, so 30 degrees, okay, is one of the results. So that was where it's equal to half, so we're going to go about there for a half. If you draw a line through a half, we can see then where the other results lie. Okay, so you've got your 30 degrees here. Of course, the other result is going to be here. Okay, so you know my graph isn't perfect, but you should see that this is 30 degrees where the curve rises here, so 30 degrees across. So it's the same sort of rise going backwards from 180. So you've got to go back then 30 degrees, just like this distance here is 30 degrees. So theta will be 30 degrees and 180 minus 30 degrees. So theta will be 30 or 150. So all our results together will be 30, 90, 150 and 270.